Hello and welcome back. So now that we're done with our canvas, I think it's time that we go on to programming. So I will create a new scene. Go ahead and click File, New Scene. And in this scene, we're going to be doing our programming. Just keep our main scene, our first scene separated so you know where we had our canvases, so you can go back and check out what we did. Let's go ahead and save this scene. Instantly, I will just call it scene 2. Okay, and anytime you create a scene, by default you will get a main camera, which will always just be what the player sees. You need the main camera in your scene for some feedback. We can change the background color of the camera to something different, but currently it's set to render a skybox. I'm just going to select a solid color and then just change the background to something. You can also click on this icon here and just click somewhere in the scene to get that color. Just choose something like this. Then we have a directional light. We'll speak about lighting in a different section, but on this one we'll focus on programming. So let's go ahead and in our scripts folder create a new script. Oops, not a new folder, a new script. Just delete this folder. New script, C# script, let's call it new script. And let's open it up. You can use Visual Studio or MonoDevelop, it doesn't really matter, the code will run the same, but I just prefer Visual Studio as a text editor. So once you create a script and it opens up, you'll get this by default. So first off, the top 3 tags, the using tags, are basically telling the script which libraries we're using. So we're using Unity Engine, System Collections.generic, and System Collections. We don't need these two currently, so we can just go ahead and delete them. You can see that they were grayed out to indicate that they haven't been used. You might recall, if we're working with Canvas, we need to say using Unity Engine.ui so that we can access some Canvas elements through our script. Later down the line, when we need something, we'll just implement a library to help us work around that. Then we have public class new script mono behavior. This means that this is a class and this is the name of the class, so it's called new script, like in Unity. If you change the name here in the script, be sure to change it in the engine, because if this is called new script and this is called something different, it won't run. And then we have mono behavior. This means that this script is a mono behavior script. Basically, that means that we can attach it to a Unity game object and it will be considered as a component, like we've done with our previous test script. So if I were to delete this script, now this will be just a normal class called new script. If I go back into Unity, and if I, let's say, create a new empty game object, if I try to drop the script here, it hasn't compiled. Let me just reload it, close it and open it again. Okay, and now you can see this, the associated script cannot be loaded. Please fix any compile error and assign a valid script. This means because this script isn't a mono behavior, it won't actually run. You see, I can't even add it to the component. Can't add script behavior new script. The script needs to derive from mono behavior. But our test script, we can easily add that in here because our test script is indeed derived from mono behavior. So let's go ahead and so keep that in mind. If we want to create a component for a game object, maybe a script that moves it, we need to specify that it is derived from mono behavior. This just means that it is derived from something. We will later speak about classes that are derived from different classes, so we can create a class. For example, if you're building an RPG game and you have enemies, characters, NPCs, all of those characters share similar things. For example, all of them will have a health bar, all of them will have maybe movement speed, maybe damage they deal, and then we would create a script, a class called maybe entity, which has some values such as health, movement speed, etc. and then for example we would have a class called npc1, and it would derive from the class entity. Currently this won't work because we haven't done anything. We'll get to that sooner. But for now, just make sure that MonoBehaviour enables a script to be added to Unity as a game object. So test script is a MonoBehaviour. We can add it here as a component, and then we have all of these different parameters that we've designed. Now that new script is also a MonoBehaviour, I can go ahead and add it as well. Well, I just need to reload it. Let me just reload the script. Okay, so it's a MonoBehaviour, and now again I can add it to a component, add it to a game object as a component, and currently this is just an empty component. So this game object, let's just call it testing object, because to run a script that is on a game well, if we write any code in our script, it won't actually execute unless it's added to a game object in the scene. Like we did in our previous scene, we had our test script added to the cube, and we done all sorts of different things with the canvas. So let's go back to our script, and you can see here we have two methods. This void update is a method, and void start is a method. Void just means that this method doesn't return any value, so that it won't return anything. Void start will be executed when the game starts, and anything that is contained within these curly brackets will be executed. So you can write code in here and it will execute when the game starts, whereas update will execute each frame of the game. Now void, as I said, means that this method won't return anything, whereas we could say maybe int method, and this, as if you create a method like this, that means that it will return a integer value. And currently this is underlined because it isn't written properly. We need to return a value here down in the code for this to be working, but we'll get to it later. Let's just start with something simple for now. So the three basic data types in programming in C# will be string, let's say name, int number, and boolean, let's say question. So string is a if I type in two of these slashes, I can write out a comment, and this is ignored by the code. So you can see this is above start. We have a comment that says use this for initialization, and then we have update is called once per frame. So you can leave comments to make things easier for you to remember, or for someone else when he comes to read your code, he can read comments and understand what this is. So we can say string name takes in strings. For example, my name is Steven. Then we have number can be from 1 to basically any number, 1 to 3, blah blah blah. Then we have question. It can either read true or false, or a 1 or a 0 in the eyes of the computer. So we used strings in our canvas, and numbers, I think, also booleans. You should be familiar with them. And if they're written like this, string, int, and boolean, that means that they're private variables. We can also say private in front of them to make sure that they are private. This means that only this script called new script can access these values. But if we say public to all of these, just say public, now our new script will have 3 new parameters here in the game object inspector tab. We have a name, and this will take in a string, so for example Steven. Then we have a number, and the number, if you notice, I can't enter any letters. I'm mashing my keyboard, but nothing happens. I can only insert a number. And then we have question, which is of type boolean, which means it can either be false or true. So checked or unchecked. So when a variable is public, that means that other scripts can access this variable and the value can be changed from the inspector tab. So this is really important to remember. Keep that in mind. So for example, when the game starts, we can just simply say, let's just simply debug.log. So what debug.log does, it will debug whatever is written in these brackets to us. So this is used for figuring out how your things work, if you have any bugs, just a really simple solution. So let's say debug.log.name, debug.log number, and debug.log question. So when the game starts, this will write out or whatever is written inside, whatever is contained inside of name, whatever is contained inside of number, and whatever is contained inside of question. So basically, variables are kind of like containers in which we put in some kind of information. And each of these containers has a type that tells him what he can store. So this container called name can store strings, names and letters, basically whatever you tell him to, whatever you write to him. This container called number can only store integers, so numbers 1, 2, 3, no text, no letters. And this question can only store a value that is either true or false, 1 or 0 in computer terms. So if I save the script and go back into Unity, let me just clear some of these warnings that we're getting. And now if I run the game, you should see down in our console we should get 3 debug.logs. And in fact we get them. We first get one that says Steven, then we get 1, 2, 3, 4, 5, and we get through. Now if we select our testing object and see our script, we can see that our name is in fact Steven, the number is 1, 2, 3, 4, 5, and the question is true. Now if I exit play mode and set this to false, change the number and change the name, now run again, we now have Kevin, 2 and false, and it works perfectly. And now the difference between start and update, we can just demonstrate that. If I cut this code from start and just paste it to update, you will see that each frame we will be getting these values from here printed in the console. So let's start that. And there we go, we see Kevin, 2 and false, and here you can see how many times it was printed. So in a few seconds it printed 400 times. Basically update is called each frame, so if your game is running at 60 frames per second, you will get 60 debug logs in a second. We can actually click on stats here, and you can see that I'm running at 75 FPS currently, and you can also see many other different statistics of your PC and how your game is running. This is really good for optimizing your game when you're developing it. Be sure to always be looking at the stats here. But there you have it. So that is some of the basics. We'll continue in the next lecture because this one is getting pretty lengthy. I'll see you then. Thank you for watching and goodbye. Hello and welcome back. So last time we kind of made the introduction about programming. We talked about comments, the basic tree data types, and the start method and the update method. Today I want to start with the if-else statement, or just the if statement. So basically an if statement is a statement that checks to see if a condition is true, and if it is, it's going to execute code that we tell it to. So let's go ahead and delete these debug logs from the update method. And let's say, so the body of a if statement looks like this. So we say if, then we have 2 brackets, and in here we define the condition that we are checking to see if it's either true or false. And then after this we can either have the curly brackets, which will indicate that if the statement in these brackets is true, we will be executing code in here. So to show you this example practically, I'm going to say if, and we can check many things, but basically this here can either be true or false. So we can say if the player has 5 health, do something. If he doesn't, then don't do that thing. So for now, we can check if question. So we can say if question is true. So you will notice I used 2 equal signs. This is used when comparing values. So this means that I'm checking to see if question is true. If I wanted to change the value of question, I would simply say question and say 1 equal signs and then say true here. This means that question becomes true. So basically we're taking this value and putting it inside of question. But if we use 2 equal signs, that means that we are comparing values. So we want to see if whatever is contained in question is true. Let's delete this from the start method. And now if question is true, I will just debug, let's say debug.log, and let's debug name, sure. So now each frame, if question is true, we will get the name debugged into Unity. So let's go ahead and back into our Unity. Let's click on the testing objects, and currently on the component, question is set to false. You can see that in the inspector tab, it hasn't been checked. So now if I were to start the game, we wouldn't get anything in our console. That's because this is checking to see if question is true. It isn't, so it won't do this. It will do other code, but there's no other code to do. Let's go back, but if I set this to be true, you can see we instantly get Kevin printed out, which is the name. Now I can disable this and the debug stop, because again the condition was true, but now it isn't. Okay, let's stop the play mode. Another way, we can also check to see if this is false. Just write in false. And now in here, if we play, it's going to be debugging Kevin, but if I enable it, it stops. Another way to write the if statement easier is like this. So this basically means if question. So we just have if and question in the brackets. This means by default if this is true. So if question is true, we will do this code. Let me demonstrate you that. Let me just clear the console. So if I run, nothing is printed out. But if I set question to be true, in fact we get our name. Okay, let's stop play mode and go back to our script. Now you might be wondering, well, how can we check to see if it's false? Well, it's really simple. We just put this symbol in front of it, this exclamation point. I forgot what it's called for a second, sorry. So this just means anything that comes after it, it's kind of negated false. So if this is true, it's going to ask if it's false. So let's save this and go back into Unity. And now if I run the game, question is false, and indeed we get a debug.log here. Now if I enable it, it stops. But of course we don't have to check the boolean question. We can check name. We can say if the name is equal to Kevin, debug.log the name. So now if I run the game, and since my name is Kevin, I get Kevin printed out. But if I were to change the name to Steven, and run the game now, it wouldn't run. So let's go back. We can also compare numbers. We can say if number is greater than, let's say 3, and we can just debug.log the number. So let's save that, and currently number is 2. Let's set it to 5 in the inspector tab. So if I run the game, we now have 5 debugged. Back in our script, so the if statement is also called the if-else statement. That's because we can say if, we can have if number is greater than 3 and some code, then we can say else. So else if this statement isn't true, we can have curly brackets, or if we only have one line of code, we can just say debug.log let's say name. We also, in this case, after if, we don't need the curly brackets because we only have one line of code, but it's good to get in a habit of using them so you don't get bugs because you forgot to put them here. So now how this code works, each frame it will check if the number is greater than 3. If it is, it will debug the number, else if it isn't, it will debug the name. So let's go back, and now let me just clear the console and run the game. Now we get a number 5 printed out because it is greater than 3, but let's change it to 1. I can change it on the fly, let me just, sorry, okay, number 1. And now we get the name printed out because indeed this statement is false, so we do else. Also, there is another way we can go about. We have if, else, and else if. So we can check if number is greater than 3. If number is greater than 3 is false. So if number is a lower number, we can say, okay, let's see if the name is Steven. And if it is, we can debug.log the name. Or else, if this statement is also false, we're just going to debug.log everything is false. So each frame it checks to see if the number is greater than 3. If it is, it will debug.log the number, so it will tell us which number that is. Else, if this isn't the case, it's going to see if the name is Steven. If it is, it's going to debug.log the name. But else, if the name isn't Steven, it's just going to say everything is false. So let us save the script and go back into Unity. Let's first set the number to be 4 and just clear the console. Now run Unity. And now we get the number debugged, but if I change it to maybe 2, we now get Steven. But if I change Steven to Kevin, we get everything is false. So now we understand how the if-else statements work. This is really useful, and you will be using this a lot in game development. For example, for movement, you want to check which button the player is pressing when for collision. You will see we will be using this. Probably we will be using the if statement 90% of the time. It's a really useful statement to know, and it's really simple. So thank you for watching. I'll see you in the next lecture. Hello and welcome. Last time we learned about if statement, if else statement, and if else if statement, and now it's time we talked about loops. So there are 4 types of loops. There is the while loop, then there is the do while loop, the for loop, and the for each loop. We'll first cover the while loop, and then we'll talk about the other ones. So loops are kind of like chunks of code that execute while until a condition is met. So basically they will iterate some kind of code a set number of times. So let's go ahead and in the start method say while, and then we have the brackets for our condition, and then the curly brackets for the code that we want to execute. So we can say while, let's say, number is greater than, let's actually say while number is less than, actually greater than 0, we can debug.log the number. And then, well, if I left it like this, this would loop to infinity, because number would always be, when the game starts, number is greater than 0, and then it will just be doing this code. So we're going to say, after we debug the number, we'll just say number minus minus. This is basically going to, each time this is done, to decrease the value of number by 1. So let's go ahead and save this and back into Unity. Our number is 4. Now if I just clear the console and if we run the game, we can see that we got 4, 3, 2, 1. So number was 4, then it has debugged 4, then we decreased 1 from the value of number, and then again it was 3, and 3 is greater than 0, so we debugged 3, then we decreased the value, so next time number was 2, and it's still greater than 0, so we debug logged 2, then we subtract, and finally it's 1, we debug 1, and then we subtract from 1, so number is now 0, and now number isn't greater than 0, so this code won't execute anymore, and in fact you see it didn't, so we only had 4 iterations of this loop. Okay, so let's go ahead and we can delete the while loop, and we can now talk about the do while loop. So it goes like do, and then we have the code that we're doing inside of these curly brackets, and now after the code we have the conditions. So now we say while, and again we can say maybe while question is true. Okay, so this will do some kind of code while question is true. So let's say we want to debug.log number, and let's just set number when the game starts. I will say that number is 0, and each time we do one of these iterations we will say number plus plus, so we'll increase the number. Okay, so now if I save this script and go back into Unity, now you'll see that question is now false, but here our code says that we're going to be doing this code while question is true. So do you think that we're going to be executing this code here? So let's go ahead and run Unity to see if something will be debug.logged, and we do in fact get a 1 here, even though question is false, and we stated that we want to do this code while question is true. So if it's false, we don't want to do it. Well, we got a debug log number because the way that the do while loop works is it first loops through the body and then it checks the condition. So the difference between a do while and a while loop is a do while will always execute once. So no matter what, this will always run one time, a minimum of one time. So it could run more times, but it will always at least run once, whereas a while loop doesn't have to run once. It runs while a condition is met. So that's the difference between a do while loop and a while loop. Now if we save this and go back into Unity, if I restart now and if I set question to be true, and now if I run the game, now we actually are stuck in an infinite loop and Unity is bugged in and it froze, because how it works, the game starts and then we do this code while question is true, but question is always true, so we're just stuck in this code here and we're never exiting the loop. So you need to be really careful with these loops. I just wanted to show you that you can be really easily stuck in an infinite loop and it will cause your engine to crash. So we will have to be careful with how we use them, not to use them in update methods or start methods. Basically, we have to make sure that we will exit out of loops. So that has been the while loop and the do while loop. Next time we'll talk about the for loop and the for each loop. Until then, thank you for watching and see you in the next lecture. Hello and welcome back. So last time we spoke about the while loop and the do while loop, and today it's time we spoke about the for loop. Now the for loop is a very useful loop. We will be using it a lot in game development and it's used a lot in programming in general. Basically what it does is it repeats some code a set amount of time. So basically it's called for because, for example, do this for 10 times, for example. So let's jump right into it and show you how it works. So I'm going to delete the do while example here and start off by saying for, and of course we need our brackets here, and let's just create our curly brackets so we don't have to worry about them later. So in our while loop and our do while loop, in our brackets we had a condition. Now a for loop is a bit different. Here we have kind of three parts of a for loop. First we have a starting point. Now it usually is defined by saying int I equals 0. This basically means that we're creating a new integer called I, and we're setting its value to be 0. So this is the starting point of this for loop. Then we set a condition that while that is true, this for loop will be executing. For example, I can say I less than number, then another semicolon, and finally I can set a what's going to be happening every time this for loop starts again. So we'll be increasing I. Now how this works, let me just debug.log. I'm going to debug.log I. Okay, so now when I start the game, number is set to 0. I don't want that. I'm going to delete it. And I'm going to take the number from the Unity Inspector tab. So let's say we set it to 5. This starts. So I becomes 0. And it says, is I less than number? If it is, then debug log I. So we should get 0 written out. Then I is going to be 1. And again, we're going to say, is I less than number? If it is, we're going to debug.log. And each time we're going to be increasing I. And we'll be doing that until I is greater than number. So let's go ahead and go back into Unity. And let me select my testing object. Okay, so number is 2. Now let's set it to 5. Oops, not 50. 5. Let me just clear my console. And now if I run it, you will see indeed I get 0, 1, 2, 3, and 4. Now you might be wondering, well, number is 5. Yes, we start from 0, and we do this until I is less than number, basically. Now this is really useful. For example, what we can do is we can get the length of a string. For example, I can say a name dot length. So what this means is basically it's going to take the string name and it's going to take in its length, and then we're going to be comparing I to the length of the name. So basically currently, oops, let me just close the play mode. Currently the name is Kevin, so Kevin has 1, 2, 3, 4, and 5 characters. So this should execute for 5 times, and let's just debug log I. Or what we could do is, let's just debug log I for now. So go back into Unity and run this, and we do in fact get 0, 1, 2, 3, and 4. I might be confused as to, well, Kevin has 5 letters, but here our last debug log is 4. Well, that's because we start from 0. In programming, usually when we're counting things, we start from 0. So don't let that confuse you. Okay. Also in here, what we can do is we don't have to increment I, we can decrease I. But then we can say that I starts from name.length. And we're going to be doing this until I is, we'll be doing this while I is greater than 0. Okay, so now if I save this, if we go back and see Kevin has 5 characters. So when we start the game, I will become 5. And then we'll check to see if it's greater than 0. If it is, we will do this. We will debug log I, then we will decrease the value of I, which is going to be 4 then. Well, you'll get the idea. Let me just now run the game. And indeed we get a 5, 4, 3, 2, and 1. Okay. For loops are really useful for many different reasons. When you want to maybe loop through something a set amount of time and just change some values. For example, we could have 5 game objects, and for each one of them I want to do something. Well, actually what we could do is take the number now. Yeah, let's do that. Let's go ahead and create a new for loop. So when the game starts, or actually let's go ahead and in update, when we press a button, we're gonna call a for loop. So let's say if, and now we get button check. We get button input by saying input dot get key down, or you can say get key, but I'm going to say get key down. So get key refers to if you can hold down the key, and it's going to be calling this code each frame. But get key down is just going to be calling it once you press it, and get key up is going to call it as soon as you release it. So what I want to do is say get key down, and oops, and in here we say key code, and then which key do we want? So I'm going to look for space, and when I press space, I'm going to increase the size of my player. So I can say for int I is equal to 0, I is less than number I plus plus. And now in here, what I can say is I can go ahead and say transform dot scale, I think local scale is equal to new vector 3, and we can go ahead and say transform dot local scale dot x times I, and then we can say transform dot local scale times dot y times I, transform dot local scale dot z times I. So now when I press space, I becomes 0, and I'm going to set the scale of my game object on x, y, and z. I'm going to multiply it by I. So I'm going to just set it to 0. Actually, let's make I start from 1. This approach will just set the size to 0 and then never reset it, because multiplying by 0 always is equal to 0. Okay, so go ahead. Now number is 5. Let me just, where's my testing object? Let me add a mesh renderer. I'm not looking for a mesh renderer. I want a, how is it called? Just a moment, please. A mesh filter, and now we add a mesh. So I want this to look. I want this to be a cube. Let me just go to my scene view. And this is a very small cube. For some reason, it's invisible. Why? I have no idea. I think we need a mesh renderer and a mesh filter. There we go. So let's set the size to be 1, 1, and 1. Go to our game. Set the position to be 0. Okay. Now it's missing a material, so it's purple. Never mind that. The script should just work just fine. So if I start now, if I press space, you can see how the scale jumped to 24. Let me just go to the script and set the number to 2. And I press space. And 2 is too small. 3. Press space, you can see how it increases. Each time I press space, it increases. And back in the scene view, you can see it's getting bigger. That's because each time we press space, we're calling this for loop, and each time we start from 1, and we do this until I is less than number, and basically we just multiply the current scale with I. Okay, so that's going to be it for the for loop. We'll be talking about it later, and you'll see more examples. If you don't understand it now, how it works, you will later, because we'll be using it a lot in game development and with examples that will make more sense. So thank you for watching, and I'll see you in the next lecture. Hello and welcome back. So last time we spoke about for loops, and finally we have a for each loop to cover. For each loops are very similar to for loops, but the only difference is that they loop through arrays. So what is an array, you might be thinking? Well, you remember how we spoke about variables and how variables are kind of like containers in which we put some kind of information. Well, arrays are containers in which we can put more of the same information. So for example, this integer isn't an array, it's just this variable is just one integer, so you can only have one value in it. In the inspector tab, if I go back to my object, you can see number, and it can only be one number. But if I were to set these two brackets here, this means that this is an array. And let's just say change the name to numbers so it makes sense. And now if I go back into Unity, I'm going to see now if this updates. Let me just go back to our script and just remove from the update method all the code we had. We won't be needing it. So now back in Unity, let me just clear the console. And now you can see numbers, and we have this drop down window here. And now it says that size is 0. And I can set the size to be 5. And now I have 5 elements here. Element 0, 1, 2, 3, and 4. And each of these is looking for a number. So let's say the first element will be 2. And then the second can be 34. Then this one can be 12. This one can be 1. And the fourth one can be 4. And now we can loop through this array and display all of these values. So let's go ahead and say it for each. For each brackets, and then what we're going to do. Now how for each works is we say for each something in something. So for each, we're going to say integer, and we'll call this integer current. For each integer current in numbers, so we're going to be looking in the array numbers. We want to say debug.log current. So let's save this and go back into Unity. Now if we start this, it should debug out, let me just clear the console, it should debug out 2, 34, 12, 1, and 4. Let's go ahead and see if that happens. And it does, we have 2, 34, 12, 1, and 4. So let me show you another really awesome example. So we can go ahead and have public game object. We can have an array of game objects, and let's call them, I don't know, cubes. And we can say, we can have a for each loop, and we want a game object which is going to be current cube in cubes. And what we want to do is, let me just save this and go back into Unity. I will come back to this in a moment. Now we have the cube size here. And let me just add a few cubes here. So cube 1, reset the position. There we go. There it is. And I'm going to duplicate it. And create another one. And just let me move these guys a little bit. Okay, so now we have these 6 cubes. And what I'm going to do is we can go to our size, and now in cubes it's going to be looking for game objects. So what we want to do, what we can do is just select our cubes. Let me just, so if we go into if we select our testing object, game object, and click on this little icon here, that means that now we have locked this inspector, and no matter what we click, it's always going to display the inspector of the testing object, which is great because now we really need this. So I'm going to select all these cubes, and I can just simply drag them into the size here, and it's going to populate the array for us. So now we have 6 cubes here, and it says which cube we can click on it, and it's going to be highlighted in Unity. And also I can drop this down. So now our array of cubes has 6 game objects, and what I want to do is when the game starts, I'm going to loop through all of these game objects, and I'm going to say current cube active equals false. So let's save that and go back into Unity. So now we can see that all of these objects, all of these cubes are active. You can see that they're visible. Let me just change the color on the main camera so you can see the cubes better. But if I start the game now, we should loop through all of these objects in the array and disable each one of them. So current cube is referring to the cube that we're currently on in the array. So firstly we'll be on the first one, and then the second one, and moving on forwards. Now .active is just going to set this little thing here to false. So just going to disable the cube. So let's start the game and see if this works. And in fact it does. You can see all of them are disabled. So there you have it for each explained. I hope you understand it. If not, don't worry, we'll be having many more examples in the near future. So we'll start with game development pretty soon. We have one more lecture. We have to cover the switch statement, and after that we'll start by developing some apps and games. Thank you for watching. I'll see you in the next lecture. Hello and welcome back. So today we'll be speaking about the switch statement. So if you remember how our if statement went, so we had if and then we had a condition. So let's say if name is equal to Steven, then we'd say, let's say debug.log first name. Then we had else do something different. Now doing things like this can take up a lot of code and be kind of awkward to read. To replace that, we have the switch statement. So how it goes, we say switch, then we have these, of course, the brackets. And now what are we switching on? So let's say we're switching on the name variable. So we switch on name, and now we have cases. So always in a switch statement you have to have a default case. So we say default, and then we have these, how is this called? I forgot, sorry. And then we, let's say debug.log default case, and then after a case we need to break it. Type in break and semicolon. Okay, now that our default case is done, we can go ahead and say case, and now we can say, so in case the name is Steven, what I want to do is I want to say debug.log the name is Steven, and then of course we break. Oops, we break. You see how I'm switching on a string. Name is of type string. If you put in an integer here, you can of course say case 1, 2, 3, whatever. So let's now say case Kevin debug.log the name is Kevin, and we break. Okay, really simple. So let's save this and go back into Unity. Let me select our object and see what the name is. So the name is Kevin. So the debug.log should say the name is Kevin, and indeed it's saying the name is Kevin, because we're switching on this variable, and the content of this variable is Kevin, so it's going to execute the code in here. If we were to change this to Steven, now it's saying the name is Steven. But notice how while I was changing the name from Kevin to Steven, it printed out default case 42 times. That's because it was so the name variable didn't have Steven nor Kevin in it, so it was running the default case. Okay, this is really simple and useful, the switch statement. We'll be using it a lot. You make sure to experiment with this with integers and other data types. So let me just delete this. So those are all basics of programming. What I want to do in the next section is create a simple calculator. So we're going to combine what we learned in this section and in the previous section with Canvas, and we're going to build a awesome simple calculator that we can later deploy to Android, iOS, or PC, so you can show off to your friends. So if you want, you can go ahead and try to do that yourself, but if you aren't confident in your abilities as of yet, and you don't think you can do it yourself, don't worry, just continue with the next lecture and we'll start off together. So thank you for watching, and I'll see you then. And goodbye.